Okay, we're on Exponents and Logarithms Part 2. We just solved 2 to the x equals 20 by trial and error, by a table, and by a graph. Okay, and now we're going to see if we can do it algebraically. And right now we need a way to undo that exponent, and we don't really know what that is yet. But we're going to see how we do other operations that way. If you have n plus 4 equals a, okay, you're adding 4 to the n. The way to undo adding 4 would be to subtract 4. So if we subtracted 4 from both sides, then we would have n equals a minus 4. Okay, then here we're multiplying the n by 3. To undo the 3 times n, we would divide by 3. And so we'd have n equals a divided by 3. Okay, then here we are squaring the n. N squared equals a. To undo the square, we square root both sides, and so we have n equals the square root of a. So we square root both sides. Now for an exponent, 2 to the n equals a, we need a way to undo the exponent, and that is called logs. And so we do log base 2 of a. Okay, and this is called, take the log, and the full name is logarithms. Logarithms. The way to undo exponents is to use logarithms. Okay, so that's what we're going to kind of learn about logarithms now. Okay, because logarithms undo exponents, they are inverses. Okay, and then how could you generate the logarithmic graph if you're given the exponential graph 2 to the x? How could we do the inverse of that? Well, to do an inverse, you switch x and y. So if a logarithm is an inverse of an exponential, we ought to be able to switch the x and y and get the graph of the log. So over here we're going to have, instead of negative 2.25, we'll have 0.25 negative 2, 0.5 negative 1, 1, 0, 2, 1, 4, 2, and 8, 3. Okay, then we're going to plot those points and see what it looks like. So 0.25, negative 2, 0.25 is over here close to the 1. The negative 2 would be down here. Okay, and then 0.5, negative 1, 1, 0, 2, 1, 4, 2, and 8, 3. Okay, and then we connect the points with a smooth curve. And we notice that it is reflected over the line y equals x, which is another definition of an inverse. Okay, so exponentials and logarithms are inverses. That means they undo each other. How do you write and read logarithms? What do their symbols look like? Okay, so if you're given an exponential equation b to the x equals a, b is the base of the exponent, x is the exponent, okay, and a would be the answer. Okay, then we write this as, we take the same base, b, and it becomes the base of the log. So this is the base. So log base b of, we take the answer, a, and that becomes what we call the argument. And then that equals the exponent, or the x. Because what a logarithm is when you do the logarithm of a number, you get the exponent. Okay, how do you read this? This is how you read it. Log base b of a equals x. Okay, so you always say log base b. So the base might be 2 or 10 or something. You always read log base 2 or whatever it is of whatever's inside the parentheses equals whatever the answer is or whatever the exponent is. Why do we use logarithms? We use them so that we can solve to solve equations where the variable is the exponent. So equations where we're trying to find what the exponent is. Okay, so we're going to practice rewriting these exponential equations as logarithm equations. And so you always start with your base. So we're going to have log base 7, and it's a little number like a subscript right kind of below the log of 49 equals the exponent, or 2. Okay, start with this base, log base 3 of 243 equals 5. And what this means is, of course, that 3 to the 5th power equals 243, and 7 to the 2nd equals 49. Okay, this one, log base, here's your base, 6 of 1 over 36 equals negative 2. Okay, and then I'm going to let you finish these all the way to here. And then we're going to go backwards here, and they're going to give us the logarithmic equation, and we're going to find the exponential equation. So we're going to go backwards, and we're going to start with the base. 2 to the exponent equals the argument, 64. This is the exponent. Okay, this is the base, x to the 2 equals 64. So you could solve for x, you could say 2 to what power would give me 64? Or what squared would give me 64? Okay, then on this one, we would start with the base. 64 squared equals x. 64 to the exponent 2 equals x. So you could find x by squaring that. Okay, then there's something called the common log, and it uses a base of 10, and it is actually on your calculator. If you look on your calculator, okay, there's a log right next to the 7. That's the common log, and that is base 10. We don't have any other bases on the calculator. Like, we don't have a button for log base 2 or log base 4, only for log base 10, and it's just called a log. Okay, so over here you can see that they've left off the base. That's because if it's not a base there, then it's really a 10. So you can write a 10 in, and then you can rewrite this as 10 to the 2 equals 100. Okay, same thing, you can put a 10 in here, and then rewrite this one. 10 to the negative 3 equals x. Okay, here you can put your 10 in, and here you can put your 10 in, and I'll let you complete those. Okay, then on the back, or on this page, all we're doing is practicing rewriting log equations into exponential equations and exponential equations into log equations. So let's start with number 1. If you wanted to change this to an exponential equation, you start with a base. 2 to the 3rd power, that's your power or your exponent, equals 8. Okay, and then you can do all these, and then down here, and does that make sense? 2 to the 3rd power, 2 times 2 times 2 is 8. Okay. Now down here we're going to write in log form. So we change this to a log form. We're going to have log, start with the base, base 2 of 16 equals 4, the exponent. So the answer to a logarithm is always an exponent. Now, make sure you make this 2 a little 2. This is a big 16, and that's a big 4. And the little 2 is down a little ways. It's like a subscript. Okay, and then you can complete the rest of these.